Okay, a single slit has a width of, okay, so our B is 0.0748 times 10 to the minus third meters. I'm not even going to try to move the decimal place on that, right? Our lambda is 524 times 10 to the minus ninth meters. And there's a pattern on the screen. This distance is 3.24. And then, of course, we want to find the distance to the screen. Okay, so what you got to know about these patterns is that this to here to here. Okay, see these evenly spaced things? There's this distance on the screen, which this represents an angle. That angle on the screen, this angle on the screen, those all have, this is what this formula is for. Those all have a width of lambda over b. Okay? They all have a width of lambda over b. So this width here is going to be 2 lambda over b. This angle between this spot and this spot is 2 lambda over b. And the reason for that is that each one of these little intervals is lambda over b. So lambda over b plus lambda over b is 2 lambda over b. That angle is also going to equal, as it always does in these problems, s over the d, right? Distance on the screen, distance to the screen, right? So we'll just set these two equal. So 2 times 524 over 0.0748 all right, is equal to the distance on the screen, so 0.0324 divided by the distance to the screen, which we don't know, right? So we can solve for this. So 0.0324 divided by 2 divided by 524 e minus 9 times 0.0748 e minus 3. Woohoo! So when I solve that for d, 2.3125 meters. That's the distance to the screen. Woohoo!